actually just about on time, so I can do a short introduction and then I'll hand over to you, Mutlu. So welcome to everyone who is joining today's session. Today's session from the Reactor London is how to accelerate the end-to-end machine learning lifecycle on Azure. So today we have Mutlu Droga as our speaker, and I will allow you to introduce yourself in the next couple of minutes. And just to, I guess, give you an overview of the Reactor before we get started. So for those of you who don't know, the Reactor is a community hub for startup and developer community groups. So what we do is provide in-house training, industry speakers, presentations, and that are all around building those communities and helping you to upskill, learn and connect. So we have reactors all over the world, and we're physical event spaces, but obviously at the moment our shift has changed to more of an online presence. So getting back to today's session, it will be recorded and will be made available on our YouTube channel within about 48 hours. I will post that link when it's available on the Meetup page. And all attendees joining today have the opportunity to ask any questions. There's a Q&A panel. I'll drop something in there in just a moment so you can see where that is. So any questions, comments, feedback, please just post that in the Q&A box. So without going any further, I will hand over to our speaker for today. So Mutlu, if you'd like to get started.
Thank you, Emma. Let me share my screen again. Can you see it?
Yeah, that's showing fine, yeah.
Perfect. So, good afternoon, everybody. Thank you for joining this session. My name is Mutlu Doğrel, as Emma introduced. I'm a senior cloud solution architect in data and AI. Working in Microsoft UK. As a CSA, I look after data and AI services, but also DevOps and serverless technologies. Prior to joining Microsoft, I did a PhD in bioinformatics, which involved the application of machine learning in computational biology problems. Today, we are going to talk about machine learning, how to accelerate the machine learning end-to-end life cycle with Azure. So the agenda is as follows. I'll do an introduction to ML AI, two words that are interchangeably used. I'll talk about some of the built-in machine learning models available on Azure and some of the APIs that come with them. Once we cover some of the built-in ML models, I'm then going to talk about how we can create custom ML models, namely how we can train and test models, then how we can deploy these models so that we can consume them, and if needed, how we can scale them if the machine learning models are going to be queried by many people at the same time. Finally, I'll finish by positioning how machine learning operations fall under the grand scheme of DevOps. Namely, we'll touch upon MLOps, how to do the management of the machine learning model creation, and then going beyond that, how can we do this using continuous integration and continuous development approaches. Finally, if you have any questions, I'll take them at the end of the call, but as Emma said, feel free to drop your questions throughout the session. So what's machine learning? Machine learning is actually not a new term. The term machine learning was coined first in 1959 by Arthur Samuel. It was defined as the ability of the computers to learn through an iterative process, a process that improves automatically through experience, and that's without being programmed explicitly. And this definition still holds true even today. AI started to be a very popular term that we hear a lot. It's a science of making the computer behave in such ways which are commonly thought to require human intelligence. Basically making a computer act human in some ways. And machine learning is simply a branch of AI. It's a study of computer algorithms that automatically become better through experience. ML is one of the ways to achieve AI. Machine learning requires large data sets to work with in order to examine and compare the information to find common patterns. Deep learning and neural networks are subclasses of machine learning. But ML is not the only way to achieve AI. There is a whole branch of statistics, simulations that you can also utilize to develop an AI system. The the most common ML strategies are supervised learning, unsupervised learning, and reinforcement learning. As I said, machine learning and statistics are closely related, but they are distinct in their principal goal. Statistics draws population inferences from a sample, while machine learning finds generalizable predictive patterns. In supervised learning, the computer is presented with example inputs and their desired outputs by a teacher. And the goal is to learn a general rule that maps inputs to outputs. Let's say you want to categorize, you want to classify a bunch of fruits, apples, watermelons, bananas. So you label these and you present them to the machine. You create a training set. You develop a model. Then you test the accuracy of the model using unseen data that wasn't presented to the machine before. If you are happy with the model, then you deploy it. But the key here is having labeled examples. Unsupervised learning has no labels required. The algorithm is left on its own to find structure in its input. Suppose I'm a t-shirt manufacturer. I have a bunch of waist and height measurements from thousands of individuals, and I want to find the best cutoffs for my t-shirt sizes. I am going to produce small, medium, large, X-large t-shirts, but I don't know quite where to, what measurements will fall under small and what measurements will fall under medium and so on. So I can utilize an unsupervised learning approach. I tell the machine, give me 4 classes. I have 4 buckets basically, and I want you to put these pairs of measurements in each of them. The closest ones will be put in the same bucket. And as I said, we present the entire data at once to the machine. There are no labels. Reinforcement learning is slightly different because it's iterative and it deals with a dynamic environment. A typical example is autonomous vehicles. So as the program navigates its problem space, it is provided feedback that's analogous to rewards, and it tries to maximize the rewards. So if a car crashes after iteration 1, then you penalize it, you don't give it a high score, the same thing really. And then you start again. This time it changes some of the parameters that it can control. It won't maybe crash in the same place, but if it does something wrong again, if it comes off its lane, then you give it again another penalty and then you start again. This way, by many iterations, it tries to optimize all these parameters that it can control. And this whole process is called reinforcement learning. It's widely used nowadays, but it doesn't quite fit into supervised and unsupervised. There are other approaches, and I don't want to go into very detail, but topic modeling, dimensionality reduction, meta learning. How can a machine learning system improve its machine learning? So these are all subfields of machine learning. And as of only 2 years ago, deep learning became the dominant approach for most of the ongoing work in the field of machine learning. Deep learning is a class of ML algorithms that uses multiple layers to progressively extract higher level features from the raw input. What I mean by that is that, consider image processing. Lower layers may identify edges in the image, basic structures, while higher layers may identify the concepts relevant to us, such as digits or letters or faces. So when I was taking neural network courses back in year 2000, I believe now, we dealt with only 1 or 2 hidden layers. So we have the input layer here at the beginning, we have a hidden layer in the middle, and an output layer, which is the prediction. And the middle layer is just a matrix of weights that are updated iteratively. Someone thought, what if we increase the number of hidden layers and let's call it deep learning and it will be a big hit? And this is what pretty much happened over the past 20 years. And deep learning neural networks are everywhere because it's for the lazy. So what I mean by that is, again, computer scientists always tries to find shortcuts, always tries to make the processes run easier, reduce the amount of manual work required. Let's take a look at shallow learning for a minute, as opposed to deep learning. I used to use support vector machines a lot during my PhD. They are still very popular, in fact. They can distinguish between different classes of data. Here we see an example of blue and red dots, but there is no easy separation. We can't find a linear separation. What they do is they implement the kernel trick, which is a function phi, that transforms this input space into a even more complex, higher dimensional space where it's easier to find a separator plane. For them to work, however, you need to provide the machine with features. By features, I mean the attributes of the objects that you want to classify. In the case of fruit classification, that can be shape, color, even some numerical value for smell. Watermelon and apple are both circular, so if you only use circularity as a metric, then they are not going to perform well. So you need to add color as well. You need to add other features for these fruits for the SVM and other even neural networks to perform well. And deep learning takes away these difficulties in the sense that you can provide the images, for instance, or the raw data directly into the machine learning system, and it takes care of looking at all the features, knowing which will be more, which will be weighted more compared to the others. So now, with that, let's talk about what's available on the Azure cloud, on the Microsoft cloud to do machine learning. ML on Azure is supported on multiple levels. We have vision APIs. So I talked about pre-built models. You can do OCR, you can do image classification out of the box. You don't need to train a deep learning model if these APIs can be sufficient for your problem. Otherwise, of course, you can also train your custom model. We have speech APIs that support speech to text, text to speech, speaker identification. We have language APIs, with which you can do text analytics, sentiment analysis, whether a sentence is positive or negative. You can do NLP, you can do entity extraction, and searches for regular search of your documents. So machine learning on Azure is not just about a particular service. You can develop with your laptop. You can run your code on your laptop. You can deploy on Azure or at the edge. It doesn't matter. So it's very flexible. You can do machine learning from the command line, from the portal, using a Jupyter notebook, an interactive script, or you can utilize the drag and drop utilities. You can use pretty much any of the popular frameworks to do machine learning: PyTorch, TensorFlow, scikit-learn. And Onyx is a machine learning format. It's an open format built to represent machine learning models. It stands for Open Neural Network Exchange. Once you create a machine learning model, you can download it as an Onyx format and deploy it elsewhere very easily. While today I'm going to mostly focus on Azure Machine Learning Service, which is a PaaS service, first-party native solution on Azure, there are other services which allows you to do machine learning, such as the Azure Databricks, or you can utilize the existing machine learning VMs on Azure. Of course, all of these are powered on top of powerful CPUs, GPUs, FPGAs that you can utilize. So, Azure Machine Learning is a service that allows you to do machine learning no matter whether you are a machine learning expert or a coding guru, or just the opposite. You have no machine learning background or you have no coding background. Sam, for instance, who doesn't know any coding or who doesn't have a machine learning background can still do machine learning on Azure by simply uploading a data set and using the automated ML functionality there, which will then scan a bunch of algorithms, optimize the parameters, and it will present the results in a visual way. Hati, on the other hand, who is an ML expert, can write any custom code she likes in PyTorch or whatever she prefers, and then can deploy these systems fully scalable. And we also have solutions for Luna and Altair as well, which I'm hoping to cover in this session as long as time allows. Machine learning end-to-end process consists of data preparation to begin with. We have data wrangling tools. You need to think about normalizing your data sets, balancing your data sets. Do you have more positive examples than negative examples? Is that going to cause a problem? We have tools that can tell you if that's the case. And you need to also think about responsible AI. Is your AI model going to favor certain ethnicities? Is your AI model going to give credits if you are a banker to only a certain group? So there are a lot of considerations when applying AI in real life. And we recently added new functionality in Azure ML that can help you with that, detect unfair behavior from AI models built. You need to assess and mitigate these harms yourselves manually, but we have tools that can detect such dangers. So once you do the preparation, you using your favorite IDE or the drag and drop method, you create a machine learning model, you test it. Once you are happy with it, you deploy it, you register model, you deploy it, you get an endpoint, an API that you can query. If it needs to be scaled out, you can put it in a cluster. If you are not going to use it very frequently, you can deploy it on a single Docker image. And the machine learning lifecycle doesn't end here. Usually people think that once they deploy their model, they are done. However, you need to monitor the accuracy of the machine learning model as it's in production, because the original data may change after, say, 1 year, 2 years. Some things in your factory, in your healthcare data, whatever the data source is, will change, and it may cause dramatic consequences in real life scenarios. So you need to monitor the data, and if there is a drift, then you need to go back, recreate another machine learning model with the new data, with the new behavior that will hopefully be better working for the current data and for the future. So we also have tools that can help you detect data drifts. Let me now talk about some of these capabilities in more detail. I mentioned the text analytics, the built-in text analytics. Once you create the service, you get a key and a URL that you can use in a Python SDK. I can share the link with you later on. This allows you to do sentiment analysis on documents or sentences in this case, such as, I hated the movie, it was so slow, what a great movie. So let me run this locally on my machine here. This is talking to a pre-built system on Azure, and it's writing some sentiments. So the first one, not surprisingly, is very positive, very negative. I hated the movie. And the second and third one are positive. The other capabilities to mention here is linked entity recognition. Albert Einstein is recognized as a linked entity, and it provides a link to Wikipedia. And it can do key phrase extraction. Redmond is a city in King County, Washington, United States, located 15 miles east of Seattle. So all of these words, as you can see, are listed as key phrases. Very recently, we added a health text entity extraction. Let me move my browser window so that you can see it. So this is the SDK for text analytics, and this is the documentation. The general categories supported in text are person. It can understand person, location, organization, and so on. Also, it can identify personally identifiable entities such as credit card number. If you want to remove these, you need to do NLP with this API. And if you want to tag your medical text, it can identify in a medical text genomic variants, gender, frequency, dosage of the medicine, and so on. Another category is speech. So let me refresh this page and switch to, I guess my accent is not United States, so I'll change it to United Kingdom. And I hope it will be at least recognizing some of my words. Yes. So let me read this part. Tailor your speech models to understand organization and industry-specific terminology. Overcome speech recognition barriers such as background noise, accents, or unique vocabulary. Customize your models by uploading audio data and transcripts. So as this text is telling us, if the generic model is not good enough for your needs, you can customize this speech model by uploading audio. If you are concerned that certain accents are not going to be recognized properly, then you can retrain it. Or if you are interested in doing speech recognition for some domains such as healthcare, then you can upload some healthcare documents, PDFs, Word documents, and so on, so that it can learn new words. Another example to a pre-built API that I want to cover very quickly now is that, because I have a lot to cover today, custom vision. Customvision.ai is the URL. It allows you to upload images. It can be anything really. Here I have some Picasso paintings. So if I click on one of them, you see they are labeled as Picasso. I can choose all of them. All of them are labeled. Once I have enough data, and ideally I should have 30 images from each category, but this was a really quick and dirty experiment. Then I click on train. It trains a deep learning model in the background very quickly. And then I can do a quick test. If I go to the web, search for Picasso painting, click on images. Let's choose one of the images. Let's say this one. I copy the image link, go back, do a quick test, paste the image link, and it's predicted as Picasso with a 99.5 probability, although I trained this system only with 7 Picasso images. It's incredible to have such an accuracy, I think, and you can improve this. So I just predicted this, and what I can do is I choose this image and I can tag the image as Picasso, save and close, go back to the training images. Now I'll have 8 Picasso images instead of 7, and then I can do a new iteration of training, and this will improve the performance. Moving on. Now I want to talk about the Azure Machine Learning Service. The Azure Machine Learning Service is at ml.azure.com. We used to have these services under different names. Microsoft Machine Learning Studio is now integrated under ml.azure.com. We integrated notebooks as well in this interface. So Azure Machine Learning Service allows you to use to run your scripts directly. If you are familiar with the Jupyter interface, you can also utilize it. You create some compute. You create your clusters for compute targets, and then you can run your notebooks in that cluster or in a single machine, or it can be a cluster of GPUs. It doesn't have to be a CPU one. Then we have automated machine learning capability for Sam, who I mentioned at the beginning, with no background of machine learning or with no background for coding. We can upload a data set from our laptop into the data sets. I just uploaded before this session a bank marketing data. I think it's some kind of credit decision whether we should give the person some credit or not. And with AutoML, what we can do is that we choose the uploaded data set, and then we assign it under an experiment. This is like a project name. I'm going to say this is a bank marketing experiment. The target column is the one that I am going to predict. So let me view the data set. This is a preview of the data. We have features such as age, education, etc., etc. And Y variable attribute here denotes whether that person received some kind of deposit or not, I think. Can we predict whether that person received a deposit or not? So that means I need to select Y as my target column that I need to make the classification model based on. Then I choose one of my existing CPU clusters. I hit next. So it asks me whether it's a classification problem, whether it's a regression problem. We are not doing a line fitting, and we are not doing time series forecasting. There is no house price prediction over a certain amount of time. It is a classification. It is binary classification. It's a yes or no. We can enable deep learning as well. And then we click finish. This will start the process. If I want to tweak some of the configuration options, I can do so. At the moment, we are optimizing accuracy. Instead, I can say, try to maximize precision, for instance, or I can change the exit criterion. I can say, don't do it beyond 24 hours. I just want you to report the best algorithm that you find within a certain period of time. So I did this experiment just before the session, actually, to save time, and I can show you the result. Here, some of the automatically populated details are entered: who ran it, what time it was started. It did some guardrails on the data, namely, is there a balance issue? And it identified the data is not well balanced. The small class, the no's or the yeses are small, 3,000, whereas the other opposite class has almost 30,000 categories. So this is no good. And it checked whether it needed to do some data imputation. The data was clean. It didn't have any high cardinality problems either. High cardinality means that, let's say you have a product list and you included the product ID as a feature in your support vector, in your machine learning problem. That is not going to be very useful in model creation, because every single product ID is going to be different. So it won't. The data that we have is okay. It's not. Doesn't have high cardinality. Here under models, you'll see all the models that it tried, all the algorithms that it tried with different parameters. It does parameter sweeping, and the best model it came up with is an XGBoost classifier that had an accuracy of over 91%, almost 92%. So if I want to go ahead and create a queryable machine learning model as a web service, I can deploy it on an AKS, Azure Kubernetes cluster. Kubernetes is an open source container orchestration system, or I can do it on a single container using the Azure Container Instance Service. So I'm not going to deploy it yet, because I'm going to show you how we can do the same thing using drag and drop, this time manually. We need to use the pipelines section here. Let's create a new pipeline. The pipeline tool allows me to drag and drop modules from here on the left-hand side. I need to import the data. I need a splitting module because I want to split my data as training and test. I'm going to use the training for creating a brand new model. So I split it, and I want 70% of my data to be in my training set. So it's really very intuitive, very easy to use. So you need to provide the import data, the data set that you need to use. So we have predefined data sets here, pre-uploaded data sets here. Let's save this and then come back to it. I go to the data sets, bank marketing data. It's sitting here. I upload it into this location. Then I can go back to pipelines. It should be available now under pipeline drafts. So I simply say I want to use my default data store, and this is the path. And I can choose the default compute target, or I can choose any of my clusters. I need a training module. The training module takes some training sets, a training data, and an algorithm such as a two-class classifier. Let's use an SVM, support vector machine. So let's put it here. and connect this with the train model. And after you have a trained model, you need to score your model. The score model requires a trained model and some test data, which we are going to provide from here. We split the data as training and test. Then we run this experiment. So I run it beforehand, again, just before the session. And it's something like that. This is marked as green because it's completed. And I put an evaluation model because I wanted to see the results, the output files, all the metrics, details about this run. Right. So if I click on it, then I can reach the same information or see this in JSON. This can give me rock curves. It shows me how accurate it is for comparison. It turned out that the accuracy wasn't as good as the AutoML. The best accuracy I could attain is 90%, whereas the AutoML did almost 92%, because even though I'm very familiar with machine learning, it's still my knowledge is limited to the algorithms that I used in the past, whereas the automated ML can systematically scan hundreds of different options for me. Now that I know the AutoML model is better than my model, I can go ahead and deploy it. That's very easy. You go to the models, you choose the best model it found, and then you click on deploy. I mentioned about this before. So in fact, again, before the session, I deployed it and I registered the model. All registered models are listed under models here, and they are versioned automatically. If I create a second model from the same data with different parameters, the version of that new model is going to be 2. If I am going to query the data, I need to look at the API endpoint from the endpoints section. Just copy this and use it programmatically in your scripts. It also comes with some kind of documentation, Swagger documentation on how to use this custom machine learning model with examples and the commands that you can send. So now we created a deployed web service. I mentioned at the beginning of the call, we also need to monitor data drift. So if your data is not static, if it's coming from an IoT device, if it's coming from a fridge, it's let's say showing you the temperature of the fridge. You built a machine learning model based on this temperature data that you had, and let's say it varied between 0 and 5, but all of a sudden it started to vary between 5 and 10 because the project changed and you didn't need to use the fridge at max power. You need to then go back and change the machine learning model, and data drift can tell you that this machine learning model is not behaving normally anymore. The data changed dramatically. Do something about it. It can send you an email. And this is available here under dataset monitors. So now this is the Azure Machine Learning service very briefly, and we keep adding new improvements to it. I mentioned fair data. I mentioned responsible AI elements already. They are already built in to the ML, and it can check whether the data set is skewed or not, whether you have more positive samples than negatives, and so on. And now I want to also talk about this Onyx one more time. So Microsoft is a contributing member of this Onyx specification. We have people working in special interest groups. It's an open source, open system, which allows you to deploy to deploy a machine learning build on your laptop, for instance, on a cloud platform, or vice versa, which is, I think, great. So now I'd like to show you how you can run machine learning using VS Code all locally. So this is a very typical example, very typical data set, MNIST, which is about digit recognition, handwritten digit recognition. It's a deep learning model using scikit. I can run it on my laptop just like a normal script, and there is no magic in it, a program running on my laptop. But what if the training starts to take hours or days? I need to do the compute on the cloud. The VS Code comes with an Azure plugin that allows you to interact with your Azure Machine Learning service. If you want, you can continue to run it locally, but you can create a virtual local compute node that will be recognized by the service on Azure. Let's call it, my VS Code is running on Ubuntu now. I'll call it Linux local. And this is the train.py is the target script. It gives me a configuration file. If I'm happy, I save and continue. I can also Dockerize my application, run it locally. The advantage of doing it like that is you can run the experiment using the Azure plugin locally, but everything, all the details, logs, the time that you run it will be captured on Azure. So that gives you a lot of power in terms of auditing, governance, security, traceability of your machine learning models. But you can also access the same compute resources that you saw on the portal that I've been using. So I can run it from my laptop. I can initiate the running of this training from my laptop, but done in the Azure ML portal. I can click on view. It will open that particular link within my Azure machine learning environment. So I think that's very convenient to have. You can install it from this website. It's called VS Code extension for Azure machine learning. Right, now I talked about the VS Code extension. I want to also mention how we can create DevOps pipelines, how a machine learning end-to-end process can be managed within a DevOps way. So in this example, I'm showing you Azure DevOps, which is a fully fledged system for doing CI/CD, It's integrated with GitHub. You can define pipelines. You can develop your application. You can collaborate with others. There is source code control, versioning control. It comes with sprint boards, everything you need in a typical DevOps world. So what I'm going to here is I'm going to create a release pipeline, or pretend to be creating it. I'll only search for the machine learning plugin. Actually, it comes with so many tools. So if you search for ML, it will put it as a step in your release pipeline. With that, you can fully automate the deployment of your machine learning model that you created within your DevOps pipeline onto a target compute. So you can customize these tasks. You give the details on the compute target, etc. So I think this is a great flexibility and a great integration. But how about doing ETL pipelines? So we have Azure Data Factory already within Azure. It allows you to do data orchestration. You can create pipelines for moving data, processing them, applying some ETL logic, and you can even call a machine learning model on top of the data. So this first step is the copy data. You specify a source and a sink. It copies it from one place to another. It can be a database. It can be the source can be another cloud. You can take it from a SQL database, put it into a data lake. From the data lake, then you can run machine learning, and then based on the results of the machine learning experiment, you can do something else. You can also link it to, let's say, Spark. You can do machine learning training. You can create new models. You can utilize existing models. So it's very comprehensive. So in the last 8 minutes or so, because I want to leave some time for the Q&A, I also want to briefly talk about this new Bonsai project. Bonsai is not machine learning, but it's a machine teaching service. It's for building intelligence into control systems and optimizing it without knowing data science and AI. It allows you to do simulations, supporting leading industrial simulators in engineering, manufacturing, energy, robotics, supply chain. Basically, you can create a model here without knowing AI or anything like that, and it uses reinforcement learning that I mentioned right at the beginning of the call. Basically, there are a few parameters that it can control, and iteratively it tries to optimize the outcome. We want to balance the ball on top of a moving plate. So it iteratively gets better and better. The goal satisfaction increases to almost here, it's 100%. And then you stop the training. You can start, you can do you can retrain it. Once you train it, you can save this as a brain and export it and deploy it on your edge device in your factory. There are different simulations supported. You can create your own simulator. You see, this is now in action. The plate is doing random movements, but the ball is not falling off. When I started, it was all over the place. You can start from the beginning by creating your own simulation. If you want to try it, go to preview.bons.ai, bonsai for bonsai. And this is in preview at the moment. Soon it will be in production. So I hope the session today gave you a good understanding of the Azure machine learning capabilities. And if you have any questions, I'd like to take a look at the screen for any questions asked. So is this the only option to get the end result through only endpoint API, or can be used the Azure SQL DB to get into? I didn't quite understand the question. So I don't know what you are referring to by if this is the only option. Can you please share links for start working on Azure Cloud? Yes, we can happily do so. We are deploying our in-house trained model as a Docker image using Azure Functions. We also connected the function to an Azure DevOps pipeline to enable CI/CD. What are some alternative deployment options? So the deployment options are, you can deploy it to Kubernetes, you can deploy it to a custom machine, you can deploy it to a Azure container instance, or if it's going to be on-prem, you can deploy it to a FPGA. Scrolling to the top. How do you make sure training data is balanced, fair, and cleaned? So it's very easy, actually. You create a machine learning model, then you test its accuracy normally. But what you really should be doing is that you should look at the recall and precision as well at the same time. There are other matrices such as F1 or Matthews correlation coefficient, which you should try to maximize, thereby increasing both sensitivity and specificity at the same time. So let me give you a very simple example for my explanation to be better understood. If you live in a place where it rains 80% of the time, and if you have a dummy machine learning predictor that tells you that it will rain every single day, it will have a 80% accuracy. It's a very good accuracy. It will be correct 80% of the time, but it's not going to predict any of the sunny days, right? And if you look at the sensitivity, it will be great. If you look at the specificity, it will be very low, close to zero. So that means you need to not only aim for accuracy, you need to aim for maximizing both of these parameters at the same time. And if your machine learning model ROC curve or the F1 coefficient, Matthews correlation coefficient are all high, that means the data is good enough. It doesn't have to be perfectly balanced, but it will be good enough. I tried Azure Machine Learning Service last year. I tried something. I coded in Jupyter a predictive ML model with linear regression or random forest with a data set. I used the same data set to train in the Azure Machine Learning drag and drop option. I used linear regression and random forest there too. When I used the test data set. I got different results from the GPT coded model and the same model in Azure ML. Why? That needs, I mean, a closer look at the script, the data, what specific algorithms used, etc. I mean, if you can send me more details, I can try to look at it. I can share some of the slides, but the recording will be available on YouTube, as Emma mentioned at the beginning. Could someone from MSFT please post into this chat the links? Let me post some of the links right now. So I post them at the end.
Great. I think there's a few more questions that are coming through, Mutlu. Thanks for getting through them all. And I think it would be really helpful. There's quite a few questions that have come through about the links for the pages that you were displaying. So it'd be great if we could get the links in there.
Sure.
Someone has just asked if this is being recorded. So I did mention in the beginning that it is being recorded and should be available within about 48 hours. And I will be posting the link on the Reactor London event page. So that's where you'll access that recording. Yeah, so just a few more questions I think came through there at the end. I'm not sure if we got them all.
Can you export your end result into Azure SQL database? So in SQL or in Synapse, it's possible to utilize a machine learning model that you built, if that's what the question is about. Basically, you can refer to a machine learning model, and then depending on the outcome of that, you can of course update your database, if that's the question. Any other questions that I missed?
I'm just having a quick look. There's one that came through KK that I've published. Is there a method for explaining the model results? Why or why not it predicted certain class or value, not statistics, please?
Yes. So under ml.azure.com, when you create a new model, it gives you a tab called explanations. That is for explaining why a certain model is working in the way it's working. Let me put the documentation link for that for you to read a bit more on that. I'm just putting it now.
Brilliant. Okay, and I think there was one more in there. So the layout of your VS Code is very organized. Is there a template available somewhere?
The VS Code plugin is the machine learning, Azure machine learning plugin, whose link I already provided. And the Onyx link is coming up. It is the Onyx format. Yeah, an interesting detail about Onyx is that AWS is also a part of it. IBM, ARM, Facebook are part of it as well. They are supporting it. It's not just Microsoft. However, Google is not, unfortunately. Thank you.
I think that's all the questions so far that we have that you've managed to get through. So thank you so much for getting around to those. Just to wrap up this session, thank you so much everyone for attending and for your brilliant questions that have come through. It's really great to see so much of you asking for the slides and asking questions about the session. So really thank you so much for that. We do have a short survey that we would love to get your feedback on. It's just to make sure that we're listening to everyone who's attending our events and how we can maybe make these sessions better. So what I will do is just post those details in the chat now. It shouldn't take more than a few minutes to complete it. So there's a link and then a event code that you need to put into the start of that survey. So that would be really very much appreciated. Mutlu, thank you so much for delivering this session.
Thank you.
Getting lots of great feedback already from people who've attended. So thank you so much.
A pleasure.
Yeah, like I mentioned, this session will be available and the recording on our YouTube channel shortly. So you'll get the link for that on our meetup page.
Perfect. Thank you all. Have a nice day. Have a nice evening, depending on where you are. Take care. All the best. Bye-bye.
Thanks. Bye.